Morning. Uh, we're going to go over the questions that were assigned yesterday, and then I'm going to give you some time to work on an assignment today. So again, looking at what we have with this is we want to, let's say we have the word office. How many different ways can I arrange the word office? Well, 6 letters. But we have 2 F's. So if you can make a word out of a problem, the solution actually isn't that bad. Okay? So we're just going to use this idea of permutations or arrangements with repetition. So we have a 14-person committee. There are 2 groups. There are women and men. That may come into account later or in other questions. Question A says it consists of chair, secretary, vice chair, and a minion. Okay? So what we have is we have one person that will be the chair, one person that will be the secretary, one person that will be vice chair, one person that will be minion, and then we have 10 other individuals who aren't on the committee. So we have a 14-letter word with 10 L's in this case. These guys are all distinct, so we could do the 1 factorial, 1 factorial, 1 factorial, 1 factorial, but I don't want to do that. That changes when we have no restrictions. We have 4 people on the committee, 10 that are lucky. So again, we have 14 factorial, 4 repeated people on the committee, 10 repeated people not on the committee. Now, be all male. So that what that does is limit us to this group here. So the 8 women, we kind of ignore. Well, we don't ignore. We're going to basically do it this way. Men, women. We need 0 women. We need 4 men. Okay? So dividing it up this way is useful if you have 3 men and 1 woman, and et cetera, et cetera. So here we have 4 men. We have 6 of them. 3 will be on the committee. 2 will be lucky. We have 8 women. All will be lucky. Okay? So we have 6 objects, 4 repeats, 2 repeats. Here we have 8 objects, all repeat. This is why I often don't do this, because there's only one way for none of the women to be on the committee. And we're going to multiply them together, because again, for every group of men, there's always one woman or one group of women that could go with it. Have exactly 3 women. Well, there's a better way of saying this: 3 women and 1 man. So again, we have to break it apart into women and men. Out of the 6 men, 1 is on the committee. 5 are lucky. Of the 8 women, 3 are on the committee, and 5 are lucky. So we've taken this problem, turned it into a word, using word very loosely, but 6 factorial over 5 factorial, and you can do the 1 factorial if you wish. Multiply, because every one of those 6 groups has these, or whatever this number works out to be, groups that could go with these 6 groups. So we've got 8 factorial over 3 factorial, 5 factorial. So this idea of making words from your problems solves so many problems that I had when I was in high school, trying to figure out which was which. I haven't even talked about permutations and combinations yet. Now, Bob and Carol can't both be on the committee. So if we